it's possible, could you go ahead and put the links to the workbook page and the solutions and the manual up there for them? So I know some of you don't have the workbook yet, and that's fine. So Jay is going to put in the chat a link to the workbook chapter 1. And remember that we have the workbook solutions. I'll share my screen really quick here. And so while she's showing you that, I'll show you in case you want to just go and do it yourself. So let me go here. Remember, you can go to robjorsted.com, unoriginal, but it's going to work. And then you could click either Physics 110 or jump straight to the workbook. So again, this is to save us time with screens and such. So the first link right here that I'm highlighting, whoops. This first link is where the questions are. And then again, down here is where the solutions are. So if you want to have those up on your machine right now, so that if the computer lags or whatever, that's we've got that taken care of. Also, on the first lecture, I forgot to plug in my wired connection. I was on wireless, so I did plug in this time. Hopefully that will be a little less audio lag. But with my kids in school and Juanita's working from home in the other room, we got, how it is these days. Everybody, it's going to happen. So if something happens where my audio cuts out, give out a shout or throw something in the chat. And you can chat with Jay or each other as much as you want. Anytime you have questions, ask Jay during the class, or you can ask me by unmuting your mic anytime you want. All right, so let's get out of this screen share for a second. So hopefully you've got all the files there, and I'm going to go to speaker view. Get me up here. Whoops, come on. There we go. All right, so hopefully this, if you're trying to view the live stream, Jay, you probably know the link for the live stream. If you could figure that out, and I think it's somewhere, could you put that in the chat for them if they need the live stream link too? Thank you. All right, it helps to have Jay here, otherwise I'd be clueless. All right, so get one more in here. All right, and so Jay is going to put the link for the live stream. Hopefully that's up and running. And again, as long as I remember to do gallery view, the people on live stream can see it. If I forget to hit gallery view, they can't, or speaker view. So I don't know if you could read this, but my goal for today is to do math with units, some conversions, and putting it together. This chapter is filled with boring stuff, but let's go ahead and get into it. And so I'm going to start in my workbook. I want to look at question 1.10. 1.10, and that's on page 7 in my book. I'm not sure where that is. So 1.10, maybe, let's do this. Okay, so all right, and I just wanted to point this out. So hopefully you've got it in front of you. If not, remember, Jay sent the link to where to look at this one. So I'm going to write this up here as well. So hopefully you don't have to waste time writing it down. So that's what we're trying to do. Is the font size big enough for you to see? Can you guys see it? Okay, I see it. All right, good. So, and if it's too small, you can unmute or just tell me something. All right, keep talking. So one of the things I want to point out now is we're doing the same thing as usual, but notice I've got the units included. This is not a big deal, but I just want to point out in a physics class, you really need to be thinking about units all the time. And so just think of the units sort of like if you did algebra where you had 23x minus 22y, you could think of the units as being like the x. It just keeps going around with it. So it's nothing crazy. Just keep the units floating around with it, just like you're doing algebra. And now, and just like this, if you had 23x minus 22x, you'd know you'd have 1x, right? So the kilometers is just going to work just like a variable in algebra. It's nothing special, but we really need to keep those with us. Now, when I'm doing an addition or subtraction, especially on a chapter 1 question for you guys, maybe whatever, I got to lean down a little bit there. But when I'm doing a chapter 1 question, I'm definitely wanting to do this subtraction like old school way. So I might actually punch this number in. And Jay, did you say, are you able to admit that person while I'm talking? Yeah, sweet. All right. Where's my calculator? Where did I put that? Here it is. So I'm just going to get this into normal notation really quick by just writing 1.012 EE. So by the way, if I hit the EE button, that means 10 to the. So right here, I'll do 1.012 EE 4, right? And that capital E means times 10 to the, whoops, sorry. That capital E means times 10 to the, and again, I just use this EE button. By doing that, I don't have to write this out and think. So now I can write this on the board. And you may be saying, this is cheesy stuff. I'm trying to give you tricks to reduce the amount of stupid mistakes you make, because as I found out yesterday in lab, stupid mistakes just kill people, right? If you don't believe me, ask Jay. They're painful. All right. So when I'm doing addition or subtraction with sig figs, I want to line this thing up this way. And now I could be a little bit careful here. So just a reminder from last time. Oh, thank you, Jay. Jay's awesome. I appreciate it. So keep in mind, how many sig figs does this top number have? Think to yourself, you don't have to say it out loud. 1, 2, 3, 4. So how many sig figs should it have when I write it a different way? Just because I write it a different way doesn't mean it should have any less sig figs. It should have 1, 2, 3, 4. So that's where I'm going to use this underline. It's strictly just to mark the sig figs. So now I remember, oh yeah, this one had 4. This one, 1, 2, 3, 4, 5 sig figs. This one's over here. I see that when I do this subtraction, this is the crappier column. Basically, the farther left you are, the lower quality result you have, right? So you have, I only know this one to the tens column, whereas I know this one to the tenths column. Not sure how well that turns out over internet, but yeah, tens versus tenths. Okay. So we're going to want to get the answer, and I don't want to screw this up. So I'm just literally going to do this on my calculator so I don't have to think. Minus 9943. And so I get 177. And now let's think about this. I want to keep the crappier column. I don't need this one because that's too precise. I go over here, it should be here. Right? This matches the column. So when you add, subtract, do a cheesy grade school looking subtraction. I still do it too whenever I need to do this. I promise you. And now when I write this down, the answer is 180. And I'm just going to keep that there. I did something wrong. Somebody tell me what I did wrong.
Is it the amount of significant figures?
Nope.
Units.
Units. So I was trying to distract you with all kinds of crap with the sig figs so that the point of this was to remind you that in a normal physics class, if you didn't write down the kilometers, you'd lose points. Now, on top of that, we have Canvas. Canvas won't let you write the units. So shit, what are you going to do? We have to practice writing these units, but then when you have to enter numbers in a Canvas quiz, you have to remember, oh yeah, Canvas doesn't let me do that. And I believe on all the Canvas quizzes that you're going to take all semester, I've specifically said in a real life situation, you should write the units, but in Canvas, you don't. So I've tried to remind you of that during the quiz, but when you're doing your work at home, I really want you to get in this habit. It would be very dumb to get in the habit of not writing units when you're supposed to write units, because that's just going to kill you for the rest of your career. All right. So please get in the habit of doing this. And then just remember that Canvas is stupid and doesn't really matter in real life. We just have to deal with it. So that's the one case. All right. I hope the people that made Canvas are listening right now. All right. So that's that. I think that's enough said on that. In a physics class, remember to keep track of your units. All right. Any questions about that? And this would be true whether it's kilometers, meters per second. Let's say you had to add 2 speeds. Maybe you wanted to figure out the relative velocity and there's a velocity calculation. You could have meters per second plus meters per second. You'd still get meters per second. So that's cool. All right. Some good problems for you to practice at home. that force you to deal with this are questions on page 7 of the workbook. So any of those questions on page 7 force you to do that. And they also go the extra step of making you do figure out prefixes and engineering notation, some stuff that we did last time. So this page 7 is great. These are the types of questions that I might throw on a chapter 1 quiz, this kind of level, where I really make you deal with prefixes, sig figs, and units all in the same question. So make sure you do a good job on page 7. All right. All right. So now after that, oh, and page 8, questions 1.16 and 1.17 are also good. They're the same kind of thing. So I want to maybe share screen for just a second so we have that. I know some of you don't have the book and it's annoying. So just to be clear, we are right here. So again, mine might look a little bit different than yours. And so let's see. Whoops. I think we're right here. All right, sorry, this is a little bit big. I gotta make it smaller. There we go. So this, I think, is page 8. Yes, hopefully yours is very similar to this. So these are some things that I'm hoping you already know. So this is stuff you should know already in theory. Now, some of you might be taking a trig class right now concurrently with this. So you might be saying, I don't know any of this, but I can talk to you more in office hours right after class. And I will tell you office hours in an email later today in general. So, but we're always going to have some office hours right after class. Okay. So these are some silly little things that I expect you to know. Now, if you don't know this stuff right now, I believe when you get your workbook, it'll be sitting there on the back. Okay. So these are the kinds of things that are showing up on the back, except for SOHCAHTOA. I think SOHCAHTOA, you just got to memorize. So if you have a hard copy, put a star next to that and say, make sure I memorize that. We're going to use this stuff all the time. All right. So just make sure that's kind of the stuff I expect you to know. All right. And you can see here's questions 1.16 and 17 to see how we might use that. I'm going to leave that for you to do at home, but if we have time, we can come back and look at that. I have a feeling if we do some of the next problems, it will cover that anyways. So just be aware of that. All right. And now I want to talk about unit conversions. Some of you may be saying, oh my gosh, this is so boring. If so, do the problems and don't listen to me, and that's great. If you don't know what I'm talking about, or maybe you want to see, just hang on there and let's do a couple problems, all right? Sorry, my head keeps getting cut off the screen, but to be honest, I could care less. All I care about is you learning something, all right? So, and let me see. I'm going to scoot just a little closer here. There we go. Just marking where I can go on the screen here. Looks, whoops, looks like I can go a little lower. Okay, so now I know my limits. All right, and so let's say we have something here, and you could look on page 9 in the workbook. Oh, sorry. Let me get back to this view. Sorry for those of you on the live stream. Now I'm back here. So, okay, so let's say we have something, a common speed might be 60 miles per hour. Okay. So, you know, 60 miles per hour is a speed. Maybe in physics, we want to convert this to meters and seconds. So our goal is convert to meters per second. All right. So if we want to convert from miles per hour to meters per second, there are lots of ways to do this. You could use Google. That's the easiest, right? However, I think it's worth seeing these. Also, I know you have to know how to do this for the Canvas quiz because I made up a bunch of stuff and I searched for it on Google and made sure it's not on Google. So you do want to actually learn how to do this for quiz 1, all right? So let's pay attention. What I want to do is in chemistry, I always make fun of chemists, but they have some really good tricks, and this is one of them. You set up what's called the railroad tracks. So what I want to do is I want to get rid of miles and get it into hours. So I'm going to look at my conversion sheet, or sorry, get rid of miles and get it into meters. All right, so I've got my conversions and I see right here, 1609 meters is a mile. So I'm going to write that down, or you can remember that from track. So I want to get rid of miles. 1609 meters equals 1 mile. And I'm told that this one is significant to 4 digits. Okay, fine. So think, if I want to get rid of miles, do I need to multiply or divide by it? And you can just think to yourself, okay, I want to cancel out the miles. I want to put something with miles in the basement. So I'll put this in the basement, 1 mile. And that means, what is this equivalent to? 1609. Now this looks funny, right? But remember, because these two things are equal, this is the same thing as multiplying by 1, right? So this thing right here is multiplying by 1. So I haven't changed the number. All right. Now, according to this, I know, let's see, I want to have hours. If you look back at your conversion sheet, this is such a common one. We want to memorize it, but it's right. Whoa, where is it? I'm upside down. I think it's right there. 3,600 seconds is 1 hour. So I know now notice in this one, in your workbook, you might even notice most of them do not have an underline. See that? In particular, this one, there's no underline there. What that means in this special case for unit conversions, whoops, sorry. If there's no underline, assume it has infinite sig figs. What do I mean by that? If there's no underline, you could assume this conversion has no effect on the sig fig calculations for the rest of the problem. Another way of saying it, this one, if it has infinite sig figs, always has more sig figs than everything else in the problem. And so this conversion factor will not be limiting your sig figs, okay? So unless otherwise specified, all unit conversions have infinite sig figs. Here we see one of the exceptions. This one I did indicate it has a finite number of sig figs. All right, so let's keep rocking and then I'll pause for questions. So right here, I want to get rid of the hours. I need hours on top. I need to get rid of, to make that equal to 1, I need the 3,600 seconds. And I'm done. Now take a look at what cancels out. Miles cancels out. Hours cancels out. And now I go to the calculator. All right. You could race along with me with your calculator as well. And like I said, the fastest way to do this is with Google. But during quiz 1, I will put something on there that I have already checked is not in Google. So if you just think you can Google your way through it, it's not going to work, okay? Because it's such an important skill. You got to know what's going on. And then in real life, you would double check this with Google. All right. So I got 26.816. And then let's do the sig figs. This one has how many sig figs? Think to yourself. Infinite. Doesn't matter. It's a unit conversion, unless otherwise specified, infinite. This one has 4. This one has infinite, right? Unless otherwise specified, it has infinite. So it doesn't matter, doesn't matter, doesn't matter. 4. This one only has 1. Okay. So, right, this is a trailing 0 left of decimal. So that means the output has, well, if I multiply 1 sig fig times 4 sig figs, I keep the smaller number of sig figs in a multiplication. Addition, subtraction, worst column. Multiplication, there. So then I would write the answer is basically 30, right? Wrong. What did I forget? Somebody unmute. Tell me.
The units.
The units. Excellent. And that's what we're trying to get used to. Again, Canvas stinks, but in real life, we should think about that. Now, I don't know about you, but this, it turns out for me and actually for Canvas and for Microsoft Excel and a lot of things that you do, you actually want to keep the extra digit. So one thing you could do, and this would be full credit on a handwritten quiz, is just say this is 27, but underline this. That way, if I need to use this number later, I actually have the extra sig figs so I avoid intermediate rounding. Again, You might be saying, what the heck is he talking about? Give me just a sec. Maybe you remember this stupid thing I was showing you, this done correctly, done incorrectly. What happens if you round too early, blah, 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 blah. Okay. In this case, let's say I did this unit conversion and need to use this number later. If I round too early, that's bad. So what I've done is I've said, okay, do the conversion, underline where it should be rounded, but keep one extra sig fig just in case I need this for a later step. Now, you're going to do this conversion hundreds of times in your life, all right? So the common thing that people do for a mistake is accidentally flipping one of these things up and down. How do you know you did this right? Take a look at the numbers. If you go from miles per hour to meters per second, it's about divide by 2. So just keep that in the back of your mind. If you're trying to go from miles per hour to meters per second or back and forth, it's about a factor of 2. Miles per hour is always faster. So if I said I'm going 15 meters per second, you know that's about, what, 30 miles per hour. And because we use meters and seconds so much in science, it's nice to know that conversion and have it memorized. So maybe that's worth making a little note to yourself. Meters per second, miles per hour, about a factor of 2. Okay. All right. So let's call that good. And I want to pause for a second and see if there's any questions here. I'll open up the chat. There's a bunch there. Hopefully Jay's been helping. Okay. Oh yeah. Okay. Getting some. Okay, cool. Thank you. Right. All right. So looks good. Yeah. Okay. So it turns out it's a print on demand book, right? So this is the cheapest way I could do it. And so if you order it, I think they will maybe take a day to resupply, and it might take them 2 days to reprint it. And remember, you've got the first chapter online, but so that should be good until the first quiz. But if you haven't ordered the book, you could see people are having trouble getting it. Make sure you get it right away. All right. So that way it'll be here for chapter 2. All right. Any questions about the unit conversion? Is that going okay? Let me go to gallery view for a sec. Just give me a thumbs up if you're doing okay with this right now. Okay, I see some. That's good. Okay, cool. And I want to go on to show you the most common way people screw up and the kind of thing I'm going to stick on the quiz question next. So I know some of you might be bored with that. Beatrice has a good question there. So remember, this has 1 sig fig. When you do the multiplication, 1 sig fig times 4 sig figs, keep the smaller number, you end up with 1. Now you could write it like this. You could keep 2 extra digits if you want. That's cool, right? You don't want to keep 5 extra because that's a waste of your time and anybody else that tries to follow your work. But you could keep 1 extra, you could keep 2 extra. But it's important, if you're going to keep any extra, make sure you indicate it with the underline where the sig figs should be, all right? Okay. Beatrice, I hope that got that question answered for you. Okay.
Thank you.
Yep, right on. Okay. Oh, yeah. So let's do one more of these. And let's do one that maybe is more similar to the quiz difficulty, okay? All right. So let's say there's a new physics unit called a taco. And let's say 1 taco equals 16.3 feet. All right. I don't know why, but that's a big taco. Now I'm hungry. Okay. And let's say there's 1 frog. I don't know why I like frog and taco. You'll see it in problems every once in a while. Let's say a frog is 7.86 seconds. And let's say these each have 3 sig figs. Okay. I don't know why. But let's say I made up a new unit called a frog and a new unit called a taco. All right. And let's say I want to convert to meters per second. All right. Convert to meters per second. And here's the number we have. 6. Oh, let's do 555. I love a good 555 reference. 555 frogs squared per tacos cubed. All right. And so here's the idea. And oh, shoot. I got to go to gallery view. Sorry, live stream. I'll be right there. There we go. Live stream. Hopefully you can see now. Now we've got the problem. So I'll just review. This is a unit that I might specify. Here's a different unit that I specify. I know these don't exist in Google. And I want to convert this to meters per, wait a minute, this isn't going to work. Let's see, frogs are equivalent to seconds. So this would be seconds squared, and tacos are equivalent to feet. So let's go to meters cubed. All right. And notice a foot somehow relates to meters. So in theory, this should work out. Frogs somehow relate to seconds. We should be able to get to seconds squared. Tacos somehow relate to feet, which is a distance, which relates to meters. So I should be able to do this now. Okay. So the idea is this. We set up our railroad tracks. And now let's just start with the frogs. Okay. So I know I want to get rid of frogs. So I'm going to put frog here. And that means I need to put seconds up top. Hopefully that's okay. Again, I'm trying to get rid of the frogs and the seconds up top. Now I write in the numbers. This is 7.86. And this one is 1. Wait, oh, I flipped it. Do you see that? A frog gets the 1. Seconds gets the 7.86. Sorry about that. And I'm just going to underline that. Okay. This is not going to get the job done. Why? Frog squared. So I need to square the frogs. Watch out. If I'm going to square the frogs, I got to square everything. All the numbers, all the units. So that's the trick you got to watch out for. If you have a squared unit or something, you got to square everything, including the numbers. So because this was squared, I squared everything in the conversion. Once you know that, the rest is easy. All right. Tacos, and I know that this tacos has got a cubed in it. So I'm going to go over here. Taco, I need taco up top, 1 taco. And then 1 taco is 16.3 feet. That's not going to get the job done, but it'll get us halfway there. Okay, this has got to be cubed. This has got to be cubed. And remember, when something's cubed, you're cubing both the unit and the number. If you don't like that, just stick a cube on every number and every unit. Okay. So that's the number cubed, the unit cubed. Now, I need to keep going because I need to get to meters, not to feet. So now I need a conversion between feet and meters, and then I need to cube it. So there's going to be some number here. I don't know if I gave this in here. You could look that up on Google. I'm just looking at my units really quick. And I don't think, so one of the things you could see, this one, so here's the issue that we have. We see that we've got, whoops, I'm looking at it upside down and backwards. It's a little tricky. One thing you could do is you could go from feet to inches and then go inches to centimeters, etc., and work this all out. Another thing you could do is you could literally just Google what's the conversion from feet to meters and do that and punch the numbers in. So I'm running out of room on my whiteboard here, but so there'd be a number here, and this is not done. We have to remember, because this is cubed, I need a cubed there, and that means I needed a cube there, I need a cube there, and I need a cube there. And so from this point, you could go ahead and work that on out after you look up these numbers. And then as a trick, before you go forwards, let's cancel out stuff. The frog squareds cancel out. The taco, let's see. Tacos cubed cancels out. And then notice the feet cubed also cancels out. And we're left with meters cubed on the bottom. And we're left with seconds squared on the top. So this should get the job done. When you're punching it in a calculator, if it gets too long, here's an old school trick. All right, maybe you don't like this, whatever. But one thing you could do is just do an extra step on paper and just do everything across the top and write the number here in the numerator. Then you could do everything on the bottom and write the number here and then punch that in. Otherwise, use parentheses, punch in everything on top, divide by, then remember your parentheses, and then stick everything on the bottom. So when you're doing it, you get multiple lines like this. Just go all the way across the top, divide, parenthesis, everything across the bottom. All right. That was a lot of stuff. So I'm going to pause for a second and see if this made any sense at all. All right. So How we doing? Is this okay? And I know a lot of you have probably seen this in chemistry, so a lot of you are probably just grinding away on the problems, and I appreciate that too. All right, I don't see a lot of questions here, so I don't see any. All right, so that's good. All right. So a couple of ways you could. Oh, go ahead.
Yeah, I had a question.
Yeah.
So I'm looking specifically at 1.18C.
1.18C, everybody. We're looking at 1.18C on page 9. Yeah, go ahead.
So I have the whole conversion table set up and everything. I have two numbers on the top that have 3 significant figures and one on the bottom that has 2. So the answer would be in 2 significant figures then?
I think so let me share a screen so we're all looking at the same thing, okay? Just a sec. I think I have the solutions ready to go right here. And you said which problem?
1.18C.
Hey, everybody, this is a cool trick. If you're looking for a problem, obviously you could open the PDF, hit Control F. Well, where am I? I can't see it. And then type in the problem number 1.18, and it won't always take you right there, but it usually will. Sometimes that number might actually be in an answer. So that's a trick. Again, open the PDF, hit Control F, and you can skip right to the solution you want. All right, so where were we? Part C, you said? Or B? I forget already. Sorry.
C.
Okay, C. Let me get this out of the way. I got so much Zoom crap going here. All right, and so... so remember, I just want to point something out here. You were saying 2 sig figs and 3 sig figs, right? How many sig figs does this number have?
2.
Infinite, because it's a conversion.
Right.
That's the trick. And then how many does this have?
Wait, infinite as well?
Infinite. Yeah, exactly. How about this one?
Infinite.
Exactly. That's the definition of an inch, by the way. They define the meter by numbers of wavelengths of cesium atoms, and then that defines the centimeter. And this is called an exact conversion to an infinite number of sig figs. So this is a weird one. This is actually exact. Okay, and this one, obviously, that's basically a prefix conversion. That always is perfect. And this is also a definition. So all of these numbers have infinite sig figs. So then it comes down to, aha, this one has 3. That's why I use 3.
Okay.
Does that help?
Yeah, that helps a lot.
Yeah, and remember, everybody, it's going to be confusing. If it's a unit conversion, you're supposed to know it has infinite unless otherwise specified, even though it doesn't look like that at all. Great question. Thanks for pointing that out. Awesome. I'm going to stop that share. Unless anybody else has a question while that's up on the screen. You can unmute if you, or just, yeah. Okay. All right, that's good. Great question. Nice job. So watch out for that on your unit conversions. Here's another thing to remember, people. Most of the time, a unit conversion does not change the sig figs of the original number. If it does, you probably did a bad job finding the number on the internet, because you could probably get more sig figs on the number off the internet so that it doesn't affect it. So that's how I try to do my assignments. Later on, you'll see that this does happen, where like you're doing a resistivity problem in Physics 163 in week 8. Hi, Jay. That'll be you having to deal with extra unit conversions that you find on the internet. All right. So, all right. Good question. All right. So there's lots of practice there for you. So that's page 9 in the workbook. Other questions? I'm going to get a screen share up. And if you have them, dump them in the chat or shout out, unmute. I want to go to this one. Let me move this out of the way. Okay, so that's unit conversions. They're not too bad. They're pretty quick. I'd want to point out something on page 10, and you could just look at my screen if you don't want to scroll around and find it. It turns out in physics, you can think of density as a unit conversion between mass and volume. That's what it does, right? If you know the density of something, you know the relationship between mass and volume. Density is a lot like a conversion factor. I know it's maybe not the way you were thinking about it, but yeah, so now I'm going to stop the screen share for a second. Come on now. There we go. Speak of you. And so if I go back to here, looks like I keep pushing it backwards a little bit. There we go. All right. So if you know about a density, oh, by the way, in chemistry, they always use capital D for density, but in physics, we don't. We're going to use capital D for diameter of wires all the time, or diameter of spheres or whatever. So we use lowercase d for distance. Oh, go ahead. Question?
Did you put it on speaker view?
I think I did. I think it should be. Yes. Thanks.
Okay, just want to make sure.
Yep. Thanks, Jay. Appreciate it. So, yeah. So density for us, we're going to use the symbol rho. Now, if you don't know how to, so this is the Greek letter rho. All right. Now, if you don't know how to draw it, it's not a P. Okay. It's important that this may seem silly, but we're going to have a capital P for pressure. We're going to have a lowercase p for momentum, and then we're going to have rho for density. And some problems will use all three in the same. So you have to learn how to write the curves correctly. So watch how I do this. All right. This may seem silly, but you got to learn somehow. Start with the bottom of the P and then go like that. So start there, go around. Rho, rho, rho your density. Got it. Okay, if you need help, I'll help you later. But for now, that's density, rho. We're writing the symbol correctly. And this is usually in units of kilograms per meter cubed. Later on, in physics 161 and 163, we'll learn there are all kinds of densities. You could have coulombs per meter cubed. You could have kilograms per meter. You could have a linear mass density. If you've ever tried to buy space on a shipping container, when you move from one state to another, you usually buy space in linear feet. So you're buying a volume based off linear density. This happens in the regular world too, not just physics is what I'm trying to say. So remember that we're going to use kilograms per meter. So if I know a mass, density is mass over volume, you're going to see that I use a capital V here. So a lot of times when I'm doing capital letters like capital P, you'll see me use this serif or this little toggle here. And so that's how I can distinguish between a lowercase v and an uppercase. I recommend that maybe you find your own way of doing that. If you like mine, great. If you don't, I understand. Right? So this is mass divided by volume. And I hope you agree. If you know density and one of these two things, you could figure out the other one, right? And that's what I mean. If you knew mass and density, you could convert that to an equivalent volume. If you knew volume and density, you could convert that to an equivalent mass. That is probably enough on that. Do the problems on page 10, 1.23 through 1.25 at home. It's basically more practice with unit conversions, but you definitely want to try that out, okay? Before I go on, I'll just see if there happens to be any questions on that. Oh, there's something in the chat. Let me see if it's something for me. Oh, it's not on speaker view, huh? Weird. Okay, strange. Or maybe it was. All right, let me see. I don't know. Yeah, so it looked like it was on speaker view on my end. Sorry. Yeah, I don't know. Hopefully it is now, but yeah. All right, so those of you on the internet live stream, sorry, my bad if that didn't work. Okay, so the questions on page 10 are easier versions of these. I believe the questions on page 11 will be the good ones for us to practice now, putting it all together. All right, I'm working on getting a standing desk, so I'm not always chopping my head off, but that's probably better for you anyway, so I don't break your monitor, right? Okay. So let's look at 1.26, page 11. Okay. Oh, okay. So 1.26, page 11. And I know some of you have probably been just working on problems, and that's awesome. That's what I wanted you to do. This might be a time to kind of come back together and actually listen to me just in case there's something I have that's useful for you, okay? So I know a lot of you are just doing problems. That's awesome. That's what you should do. This is the time where you may want to listen for a few minutes just in case, okay? We're going to try and put all this together, 1.26. And I'll share my screen for just a second, just so I can get it up here. I want to look at, whoops, come on. This problem right here. There. All right, so I'll give you a second to look at that, and I'm going to get it drawn on the whiteboard as well. so you could read it. I'm just drawing it here on my screen as well. So you've got it. If you want to start and get ahead of me, that's fine. All right. So I got all that stuff written down now. All right. Hopefully it's on speaker view now for those of you on live stream. So notice I've been doing physics for, gosh, I don't know, 20, 30 years, right? And I wrote this book, so I know this problem inside and out. But I still did this. I still took everything that was in the book and put it on my paper. Why? So it's easier for me to work, so I'm not going back and forth. By writing everything down on your paper, we basically written down everything that was given to you. You know that you didn't miss anything in the problem. You know what you have to work with without having to keep reading the damn problem all the time. I've got my picture on my paper, not in the book. This is what you should be doing. I know this may seem silly, but this is one of the bigger things to get out of this class is do your work in a good way to reduce mistakes, reduce headaches, and basically be more efficient. Get the information on your paper, not in the workbook. Get in that habit, okay? All right. So, and now I don't know if these numbers are realistic or not. In fact, they're probably not because I made them up and I was deliberately trying to make it be sneaky. So that means it's usually not perfectly realistic. But that said, okay, that's fine. It's not outrageous. I don't know. Are we making this thing out of gold? Yeah. So, all right, we have a gold nut here. This is ridiculous. All right. Now, before I even, go any further, this would be a good time to read the problem and let's see what we're trying to do. Before I just blindly start calculating, I'm going to read that problem and notice the first step says determine this crap in terms of the letters. This is another huge deal in physics. You want to learn how to do the calculations with letters, not numbers. Why? Because eventually you could take all of these things, put it in an Excel spreadsheet, and then you could say, well, I've got a formula in my spreadsheet based off of my algebra. Then I could put in any numbers I want, and I could get the mass of any nut. And it saves me time in the long run as an engineer. So that's why you got to get in this habit of doing things algebraically. All right. Now, in this case, I see that this is, well, you know what? I'll pause. Maybe, well, you guys have the solutions. Maybe I'll just talk. All right. Sorry. In a lecture, I would be asking you, but since it's so hard to do feedback, maybe I won't. I hope you could see that this nut is comprised of two pieces, basically. We've got the box and then the hole. So the idea is to get the volume of metal here, I need to do the volume of a box minus the volume of the whole. I hope that part seems okay. And if not, so I know that the volume of the nut is the volume of the box minus the volume of the hole. And you could use B or box. You could write the words. You could write box and hole here if you wanted. Okay. The box, what's the equation of volume for a box? Think to yourself, and remember, if you get stuck on that kind of thing, it's on the back page, right? It's on the back page of the workbook here, probably up in the top somewhere. All right. And so that's going to be length times width times height. And again, normally in a real class, I would be more interactive with you. It's just so crappy over Zoom. I don't know. We'll work on it. So that's length times width times height. That's the volume of a box. Okay, the volume of the hole, think to yourself, what shape is that hole? And hopefully you're thinking about it. I would say it's a cylinder, right? And it's a right cylinder. So that's going to be pi radius squared times the height, right? Maybe I'll write that as a capital R so it stands out better. Okay. Now this is what makes sense to us. However, sorry, that's a little sloppy there. I was not given those letters. If you read part A, that says it has to be in terms of D, S, and T. My answer is not good enough yet. I have to be in terms of, so let's look at this one. Well, length is S, width is S, and height in this case is T. So this would be S squared T. Length is S, width is S, height is T. Now in this case, I don't have the radius, do I? What were we given? Diameter. So it's diameter over 2. That's how you get there. And don't forget, it was squared somewhere, wasn't it? Yeah, right there. Be careful. One more common mistake is people remember to square the D, but forget to square the 2. This whole thing inside of here is the radius. So when you square that, you're going to get a D squared over 4. All right. And then what's the height I should use? You can think to yourself. Oops. T. Okay. And now this is a little bit ugly. We could maybe clean it up a little bit. You know, so let's do that one extra step. What's one thing they all have in common? T, so I could factor that out. So it's going to be T times the quantity S squared for the first one minus, when I work this all out, I should get a pi, and then I should get diameter squared over 4, because I got to square both. Excuse me. I don't know there. All right. All right. Thoughts on that? Is that working out okay? And I'm going to switch out of this view for a sec, just so I could see more people.
Would we get docked if we did not factor out the T?
No, yeah. So I think you should at least square this. But if you just wrote this, so that was a good question. Let's say you wrote S squared T minus pi diameter squared over 4T. I think that's also just as good, don't you? I think either one of those. I do think you should remember to square this and get the 4 right, because this is a little bit cleaner. And in fact, if you wanted to, you could even punch this number into a calculator and change it to a decimal number to make it even cleaner.
Okay. So
by that, just to make sure, right? I know we're on Zoom and stuff. So I could do pi divided by 4. You could even write, sorry, this would be another way. You could say S squared T minus, I'm running out of room, 0.7854 D squared T, right? And this is also correct. Now you may be saying, shouldn't I, in a math class, this is better. In an engineering condition, this is probably a little bit better. Why? In an engineering application, you're never going to need more than 3 sig figs, or very rarely. So if you write this to 4 sig figs, you know it has 1 more sig fig than every other number you're going to use. And this is a little bit easier to compute in a computer program. It takes 1 less step. Maybe this saves your computer program 1 tiny step per cycle, and this might be slightly more efficient. So, and like I said, maybe there's a reason to group it this way or that way if you're in computer science as well. Let's leave it at that. That was a great question. I think that was Christian, right?
Yeah, thank you.
Right on. Did I address yours?
Yeah, thanks.
Cool. Other questions? Oh, I forgot to, I'm going to put this on speaker for you for a second. Sorry, those of you on the live stream, I forgot to do this, but these are some alternate ways you could write that. And that's what I was just saying. Sorry, I forgot. Okay, I'll try and remember next time. Okay, other questions? All right. Okay, we are cruising right now. That was actually most of what I wanted to get done today. I think it would be a good time to maybe let you work for a second and see if you can come up with some questions while I'm still here in the room with you. And then we can, okay, so you guys start working on some questions. If you want, you could try, say, 1.28 right now, okay? Or if you're feeling sneaky, you could try 1.29, a hexagonal net. That's one of my favorites. And remember, you could keep asking questions in chat, or you can just unmute or do whatever. I don't care if your cameras are on or off. Do whatever makes you comfortable. And then I'm going to check something here to see where we're at. Let's see here. And I'm going to check something where we're at in terms of when the quiz is coming, et cetera, too, and how many class days we have. Had it written out somewhere. Come on now. I think it's this one. Yeah, I think we're doing pretty good. So I just looked at the schedule. We have 1 more class day before the quiz. So that will be next Monday. And then you have a quiz next Wednesday. And we only have 1 more major topic in chapter 1 to cover. So it does make sense. Let's take the rest of the time today just doing problems like this before I just introduce something new. Then just lose everything we just worked on. So maybe what I'll do is, yeah, you guys can work. I don't know. I'm not a big fan of the breakout rooms, but if you guys are interested in that, I could do that. But I was just going to say, work with whoever you want in class, or just work on your own. Ask questions anytime you want. You could chat with Jay. If you don't like me, you can chat with me, whatever. You could unmute, do anything. Okay. If you don't want to listen to me, turn your speaker down. Right. So I might go around and just start asking people how they're doing and what they're working on. If you don't want to hear that, just turn your volume down or something, okay? Woofda.
Professor Jorstad.
Yes, who's that? Oh, Jay? Yeah.
Andrew is asking, what are all the recommended questions for next class?
Oh, that's a good question. So I think anything up to 1.32 we can do. And I don't remember what I said was required or recommended. Thanks. Thanks for bringing that up. So I'll write this in the chat. And I will put something in a good question there. just finding the list of problems here. Yeah, and so remember that, whoops, that's not what I want. I want this one. Remember that if you go into the class on Canvas, it will tell you which problems were actually required. So you could go to this one right here, the Physics 110, and then you could click the homework for semester, and it'll tell you all the stuff that's required. So if you haven't had a chance, if you're able to print this out, it might be worth it to kind of get that too. So it looks like 29, 30, and 32 are optional. Some of those I really love, but yeah. Okay. Good question. I think I did that correct. So they're in the chat. So yeah, and we've been covering a lot. If you're like, geez, I'm only on problem 6, that's okay. You've got the weekend to catch up, right? So I've been trying to cover things so that you have the time this weekend and you're not like, oh, he didn't cover that in class. So I know I covered a lot of stuff. I don't expect you to be anywhere close to 30 yet. All right. You should be hopefully getting maybe close to 10. All right. Okay. So how are you doing, Willie? Okay. Okay. Which problem are you working on right now?
1.28.
Okay, gotcha. All right, cool. I'll let you have some fun. All right. So how about you, Christopher? Are you doing okay, Christopher?
Yeah, I'm doing okay, Professor.
Okay, which one you working on?
1.29.
I gotcha. Cool. Oh, by the way, people, if I'm coming around and you don't want to talk to me, just give me a thumbs up or something, or just say go away. All right. But I am just going to go through the list here as they appear on my screen. Eli, how are you doing? Okay. Right on. Daniel? Cool. Oh, whoa, double Daniel back to back. That was cool. There's Daniel A and Daniel G. So that's cool. You guys happen to be right next to each other. Thanks. How about you, Andrew? Good? Cool. Luke? Sweet. Gage? That's cool. We got 2 Franks. Are you guys related at all or just pure coincidence? Oh, okay. All right. That's cool. All right. But you're both doing all right? Okay. Isai? Good? Did I say that right or was that terrible? How do you say? Oh, okay, cool. Right on. Alan? Good? All right, cool. Edgar, you doing all right? Cool. Right on. Elsa?
Good. Thank you.
Okay, cool. Robert? Right on. Waller? I don't know what the S says. Is that Staff Sergeant? Is that what that is?
I'm good, thank you.
Okay, cool. Is that what the SSGT means, or I have no idea?
Yeah, I thought I changed it, but apparently not.
Oh, that's all right. That's cool. That's fine. But it sounds like you're doing okay. I'll leave you alone. Beatrice, you still doing all right?
Yes, everything's good. Thank you.
Sweet. Francisco? Cool. Alyssa? Isaac?
I'm fine, thank you.
Cool. Annette? Right on. Ruth? Gio? Right on. AM? Is that AM? I don't know. All right, cool. Christian?
Doing good, thanks.
Sweet. Ivan?
I'm doing good.
Cool. Is Ivan okay, or do you like different pronunciation?
Yeah.
That's all right?
Ivan's fine.
Okay, cool. Adalberto? All right. Angel or Angel?
Doing good.
All right, cool. If I say Angel, is that going to get me in trouble or no?
Oh, no, that's fine.
Okay, cool. Because I'm really bad with names. I don't know. I'm just about as white as they come, I guess. Artemio? All right, cool. And Julio?
Doing good.
Right on, right on. Okay, cool. I'm going to shut up. And if you have questions, ask me. And all right, I'll just sit here waiting. Easy money, Jay. You can do a problem if you need to on 163, all right? So we're almost done for today, and I'm going to go ahead and stop the live stream right after this. I'll still be here for the next half hour or something, but I want to point something out really quick. I just took the time to go through some questions, and I made up a fake quiz out of the homework problems if you wanted to say, like, time yourself in practice. So you may not want to do this right away. You might wait until after Monday's content, or you could do just these 4 parts. The reason why is this problem is going to be from the stuff that we covered next Monday, but all the rest of them we've kind of done already, like I said. So I wrote the problem numbers up here. If you want to take a quick screenshot or something, you can. And that would be some problems you could practice if you wanted to make yourself a fake quiz. I know it's kind of weird when you're doing a quiz and you don't have any clue. So that's the kind of content that maybe you might expect. And you might not get all of that. Maybe I would pick one of those and throw them out so you could do it in a timely manner. And I might pick one for, maybe I'd throw out these 2 for one class and these 2 for the other class or something. That way you guys have different quizzes in the different AM and PM sections. So you're not going to get the same stuff. Anyways, just thought I'd let you know that. So I'm going to go ahead and stop the live stream, but stick around, okay? Because that's got to be really boring on